Welcome to EDU World Space.
In this problem, we'll estimate this infinite series correct to 5 decimal places. So to do that, we should go ahead and use the upper bound given in this section for the error when using n terms. So what we mean by that is that you're looking at the nth partial sum from 1 to capital N and an, where an is given by this over here. Now, the upper bound for this expression is given in this section, and for r capital N, this will be the integral capital N to infinity, and then f of x dx, where f of x is given by replacing n with x in an. And because n is at least 1, that implies x is at least 1. So that tells us that over here, we can rewrite this integral by just replacing f with the formula. Now we like to start thinking about what technique we should use to integrate this. But before we do that, since we want to be correct to 5 decimal places, that tells us that we should take the error to be no larger than the following. That way, when we round off, this will be correct to 5 decimal places. And yeah. So this, I guess before we go on, we could just write this scientific notation. You'll see why that'll be helpful in a few moments. So now let's go ahead and solve this inequality given by this here. We would like to solve that for capital N. Because if we can do that, that'll let us know how to compute this partial sum. And we'll have our answer. So I'll go on to the next page for some more room here. And we have an improper integral on the left. And this decimal on the right. So in this case, you can go ahead and use the u substitution for the integral. Put that 1/2 due to this. And then it's up to you whether or not you want to change the limits or back substitute. But if you want to keep things in terms of u, then the lower limit becomes 2n plus 1. And the upper limit, if you plug infinity, multiply it by 2 and add 1, well, that's still infinity. So that doesn't change. So we use the u substitution to change the limits of integration there. Now this, you recognize you could use the power rule here. And then simplify that. And now finally, bring in that inequality. So if we bring, in this case, let's just go ahead and solve this for n again. So simplifying this, we'll end up with 2n plus 1 larger than 5. So at this point, you can go ahead and multiply the 10 to the other side. And when you do that, you'll get 5 times 10 to the minus 5. And then raise both sides to the 1/5 power. Simplify. In any case, with this inequality, we have n to be at least 2. So in this case, you can just use S2 as an approximation. So this will be approximately equal to the infinite sum. And then this in the calculator and so that's our approximation, which is correct up to 5 decimal places.